Welcome to solverfy.
Hello, here the system shown in the screen is initially at the rest, and then at a certain point of time it starts to move. So the mass m small is unknown, and it's connected to the mass m capital of 2 kilograms through a block. And here we have to calculate the maximum value of mass at which the system doesn't move. So let's first look at the forces which exert in this system. The first one is a gravity acting on a big block. It's m capital G. And it's countered with a tension of the rope. On the other hand, according to the third Newton's law, the same tension is exerting on the small block, which is on the incline. And besides from this tension, the block is exerting gravity, reaction of the incline, and also the friction force. And for the direction of the friction force, we will just leave it uh, like this for now. So it's basically plus minus F. And this friction force is static. Let's introduce the axis for the small block, x to the right, upwards the incline, and y to the top perpendicular to the incline. So therefore, this is angle alpha, and gx equals to negative g sine alpha, and gy equals to negative g cosine alpha. So now this system, let's imagine that this system at the rest. Then overall acceleration is 0, and the friction coefficient equals to the coefficient of the static friction. So now let's write down the second Newton's law for the big block. So T plus m capital G equals to 0. Then mg equals to T. Now let's write down the second Newton's law for the first block, for the small block. So T, vector sum T, mg, n, and f equals to 0. So now let's project it onto y-axis. On the y-axis, n equals to mg sine alpha. Oh, sorry, mg cosine alpha. And on the x-axis, t equals to mg sine alpha plus minus friction force. Basically, the plus minus friction force comes from the fact that we don't know which direction it is located at. So it can be directed towards both positive and negative x, and here we have to come up with a solution which corresponds to the smallest, which corresponds to the maximum mass. And also we have an equation that the friction force, absolute value of the friction force equals to the coefficient of the static friction times n, or coefficient of the static friction times mg cosine alpha. Now let's combine these equations together. Okay, now let's get rid of g. And let's express m from the right part of the equation. So therefore m small equals to m capital over sine alpha plus minus mu cosine alpha. And here it's m is maximum when it equals to m sine over sine alpha minus mu cosine alpha, because this denominator is lower. This denominator is lower, then the whole fraction is greater. So it equals to 2 kilograms over 2 kilograms over sine 20 degree minus 0.3 times cosine 20 degree. Now we can calculate this value. It equals to 33.3 kilograms. Let me check myself. Yeah, so that's the maximum mass of the block under which the system will be at the rest. So basically, yeah, let's analyze this result. So here we are taking that this sign is negative. So then we pick up negative sign here, 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 and here. So basically it means that it occurs when the force, friction force, with static friction is directed upwards. So here is a solution of this problem. I hope I helped you. Thank you very much for your time.